Our next speaker from Marvell is Nigel Alvarez. He's a VP of SSD and Data Center Storage Solutions, where he's responsible for SSD controllers and data storage chipsets. Big responsibility for a big manufacturer in that area. He previously worked at Inphi, helping with the efforts to make the chipsets for NVDIMMs, and is a founding member of PMCCR's Enterprise Storage Division. I was talking to him backstage a little bit. He's got a couple of kids that he's kind of proud of. One of them's a member of the Junior Sharks hockey, and that's his son, and his daughter is over at West Valley Gymnastics, learning to become a gymnast pro. So, you know, it's just kind of nice to look back and see you know, things like that going on in the future. Anyway, I'd like you to welcome Nigel to the stage, please. Nigel.
Thanks, Jim. Appreciate it. Clicker. Great. Well, welcome. I'm pretty excited. It's a phenomenal story. You know, just sitting back and talking to Jay Kramer. First FMS I attended was actually in 2007. And that was at the Santa Clara Marriott on Mission College. And the audience, you know, who attended that was maybe 100 people. And you look, you know, fast forward 10 years, 11 years now, and we're up to over 6,300 people at this summit. It's just phenomenal to see what's happening in our industry. So today, I want to share with you a couple of innovations that Marvell's been developing to really drive the next generation data center. So if you look what's going on over the last, you know, let's say about 30 years, 35 years in our generation, there's been multiple innovations that disrupt the economy and drive the economy from a productivity perspective. And, you know, when I was growing up, the PC in the 80s disrupted, you know, and created a lot of productivity that changed our lives. And then you fast forward another 10 years after that, or a dozen years, and you had the advent of the internet. And we all know what happened with the internet. It flattened the world, and it actually helped us even drive more industries and more new business models. Then the third wave came in with the iPhone and the app models that created other industries and how we do things today, of purchasing online and meeting people and communicating real time with chats using the smartphone. Now, over the last, say, 7 to 10 years, you've actually entered this cloud era where you've actually been able to optimize and become more efficient from a data sharing perspective, data management perspective, and that's leading to what we like to call now at Marvell the data era. And this is the era where the data is driving the economy. So viewed as the data economy. And you look at some of these valuations of companies like Uber and multiple other startups, you see their valuations are driven not only by the business models they're driving, but the amount of data they're gathering. And when you look at this, the amount of data that keeps piling on every wave just continues to grow, grow, grow. And that actually is going to drive new infrastructure. Because today's infrastructure is not optimal for where this is going, right? You have autonomous cars, IoT devices, industrial robots. You're going to have more and more data being created. And you have to come up with new architecture and infrastructure to address that. And we like to call it the mega-scale software-defined infrastructure. So this phenomena, or the latest wave, is obviously creating more and more increasing data generation. And this drives new and new data center workloads. And what's crazy about this is you can't even predict what the next workload is going to look like tomorrow, which makes it really challenging if you're an infrastructure manager, right? You don't know what you have to support in the future. So if you're designing and architecting a data center, you got to really take into account what infrastructure can be flexible, composable, and software driven. And this is a very critical point that you have to start designing and architecting, especially the building blocks where Marvell and companies like Xilinx and Intel are at. You got to start developing technology that drives and enables that. You know, as Jim mentioned, my son plays for the Junior Sharks. I'm a Canadian, and using the hockey analogy that Wayne Gretzky said, is as a hockey player, you don't want to be where the puck is today. You want to be where the puck's going to be at. And this is where, as semiconductor companies, you got to be foreseeing where this infrastructure is going to go. And today, what I'm going to share, and I'm very excited about the product we announced over the last day, is actually going to help these data centers scale and meet the requirements that the data center operators require. So if you're a data center client, so when I say data center client, think about AWS, Microsoft Azure, Google Cloud. They're renting CPU cycles, they're renting storage, they're renting networking, and their customers all have different needs for their application, and this obviously varies. I've shown a couple of examples of the critical optimal resources needed for their application. This varies by use case. You have your compute and DRAM, which are usually tied together. You got your networking, which is connecting everything together and then servicing it out to the end markets. You got your storage class memory that Rob talked about earlier today with the Optane type of drives and memory. You got your SATA and NVMe storage SSDs. You got SAS and SATA HDDs, which are not going anywhere anytime soon and will continue to grow in the data centers. And then you have the areas that Manish just talked about, accelerators, be it GPUs, be it application accelerators, it could be FPGA, it could be ASICs. But this shows you all the different pieces and resources that need to be managed in a manner that optimizes the end customer's requirements. So the underlying infrastructure obviously needs to be very flexible and scalable. Today, most data centers are utilizing a software-defined converged server, and I'll talk about this in a little bit more details. But this is an infrastructure that started, I want to say over 15 years ago, and Google actually started it with a converged type of server box, and now you have companies like Nutanix and others deploying that in the enterprise. And then a few years ago, I want to say about 5 to 7 years ago, the innovators started to disaggregate their infrastructure, starting with storage. So today I'll walk through these different architectures and what is the challenge there, and then what Marvell is bringing to the table to actually disrupt this and revolutionize how you disaggregate going forward. So today's converged server infrastructure is more or less where you have the IT managers and the OEMs that are designing server boxes that have a fine balance of having your hard drive, your SSD, and your compute with a NIC. Now, there's a fine balance here where you're trying to do efficiencies. It's like Southwest, where they have one plane that they fly everywhere, one type of plane, right? Why do they do that? Because it's easier to manage, lower maintenance, very straightforward. The data center guys are doing that too. They have a common building block, easy to replace, easy to manage, same parts. Sounds great in theory. Now, fast forward, with the data center workloads changing so quickly, you're challenged to anticipate what the workload's going to look like. So this growth curve, today I put all these SSDs, but guess what? They're just streaming videos and HDDs is good enough. I'm underutilizing my box. Or the other example, I put SSDs in there, but I didn't put enough SSDs, so now I'm too little, right? So this is a fundamental challenge that this converged server infrastructure has. Now, going forward, as I mentioned, as the data center requirements evolve because of the applications and because of the new business models of hosting infrastructure or renting infrastructure, you have to change the way you build these data centers. So fast forward, the disaggregated storage solutions being deployed today, what do? They slimmed down the compute server, they took out the HDDs, they took out most of the SSDs, maybe left a couple of M.2 SSDs in there, and they build a disaggregated HDD JBOD. So this is a nice JBOD. You got a compute engine in there. You got your NIC. You got maybe your SAS expanders, SAS controllers. You're talking to the backside. This happened over the last few years and continues to get deployed. Now look at SSD storage, disaggregated SSD storage. You have multiple SSDs sitting behind a compute engine, maybe a PCIe switch in between, and a NIC. Looks good, at a high level, but guess what? This specific area is very, very power hungry, adds latency, and just not very cost effective. When you look at each SSD there, and I'll show this in the next slide, is able to do 25 gigabits per second of throughput. Guess what? That NIC sitting in the front is only 100 gig NICs, best case, maybe 200. So guess what? You saturate your NIC after 4 drives. So the data center operator, he's buying all these SSDs, and he's going to end up not getting the performance out of it. This is a significant, significant bottleneck. Forget about the power. Forget about the extra BOM. The performance he's getting out of that storage is not efficient. This is what I like to call oversubscribing the dollar SSDs, very expensive SSDs. These are not QLC SSDs. These are your performance SSDs. It does not make any sense to have that behind a compute complex and behind the NIC, because that becomes your big bottleneck. It's very significant. So how significant is this bottleneck? Let's start zeroing in. One NVMe SSD today, assuming you have a high-performance SSD that Marvell's controller's in, you'll get up to 32 gigabits per second if you're getting full throughput. It doesn't happen, so let's say you discount it 10 to 15%. You're at 28 gigabits per second, 25 gigabits per second. 25 gig is probably the right number. Now move to PCIe Gen 4. I think Andrew at Microsemi will talk about this a little later on. That's 64 gigabits per second. Wow, that's a lot of bandwidth, right? And just imagine putting multiple of those behind. You'll see what the bottleneck starts to skyrocket. PCIe Gen 5, that's even more out there, right? 128 gigabits per second on an SSD. Now this might not be an SSD, it might be storage class memory in the future, right? But put 24 of those in a 2U box, you need 768 gigabits per second out of that NIC and that CPU complex. That's not happening anytime soon. Fast forward, 1.5 terabit per second, then 3 terabit per second. Wow, this is an impossible problem to solve using that architecture. And this is why the architecture has to change. The bandwidth pipe there is too small, and it's just never going to catch up, and it's never going to be power efficient, cost efficient. TCO is so significant for these data centers. You got to imagine that chart I showed you with the waves. These data centers today are football fields. Tomorrow are going to be ocean sizes, right? You already saw Microsoft dropping stuff into the ocean for data centers. The amount of compute power that needs to go into a data center is unimaginable right now. It's this exascale like Manish talked about. We have a phenomenal opportunity and problem to solve here. And I think what we're going to talk about here in my next couple of slides is how we have a new architecture for scaling storage in a linear, low latency, high performance manner. And I think this is very critical for all of you to understand, is an SSD, as the performance starts to get faster and faster because of the pipes and the NAND capabilities, combined with the fact you have new emerging memories coming into play. You have the 3D crosspoint from our friends at Intel and Micron. You got the low latency NAND XL flash from our friends at Toshiba. You got ZNAND from Samsung. So you got these medias that are starting to get faster and faster, and putting it behind the CPU complex is just wasting a lot of dollars, and you're not getting the performance, right? So let's talk about how do we address this with a new architecture. So I'd like to introduce a revolutionary disaggregation building block. And this is something Marvell announced yesterday. It's the industry's first NVMe over Fabric SSD converter controller. What does that mean? This is a new category, new product area. What this is it takes any by 4 NVMe SSD and converts it into a 25 gig NVMe over Fabric SSD. Okay? This is a significant innovation because it enables you to take anyone's SSD by 4 NVMe SSD and give it Ethernet ports and lets it disaggregate in new architectures that I'll show in a few slides. Now, getting under the hood to say, oh, well, that's great, that's nice, Nigel. What does that mean? How much latency? Well, the latency is less than a microsecond. It's less than 750 nanoseconds. So the latency is almost zero from a perspective of an SSD, because SSD latencies are in the 50 to 150, 200 microseconds. So this is adding less than a percentage of latency. It gives you up to 700K IOPS, and the power is less than a watt and a half. And it's in a really small package, which enables you to do a lot of creative stuff, right? When I say creative stuff, it lets you go into new emerging EDSFF form factors, new creative backplane designs that we'll share here in a few minutes. So it takes any NVMe by 4 SSD and turns it into an NVMe over Fabric SSD by putting this controller on an interposer type of card and changes it. And then, as I highlighted, it takes any SCM NVMe SSD, so our good friends at Intel's Optane drives, now I can plug them into the network as well. So let's see, how does that look for tomorrow? So one use case is, let me just connect my SSD to the top of rack switch. I can now have a high-performance 700K IOPS drive that's shared by all my servers, right? That's one use case, very simple. Two is, okay, I need lower latency. Plugs in the SCM NVMe SSD that becomes an NVMe or Fabric SCM SSD. So that's one architecture, and you could call this top-of-rack, low-latency, linear, scalable NVMe over Fabric SSDs and SCM. Very simple use case, and it's a good stepping stone to start the evolution. But the real opportunity going forward is coming up with an end-to-end NVMe over Fabric EBOF, Ethernet bunch of flash. Why is this exciting? You can now linearly scale in that box performance. So every time you add one of these NVMe over Fabric drives, you get 700,000 IOPS. So guess what? In a 24 NVMe 2U box, you're getting up to 16 million IOPS. Think about that for a minute. 16 million IOPS. There's no CPU that's going to be able to saturate that. That's why when it's disaggregated, you have multiple CPU servers going after this storage. This is a revolutionary architecture to scale performance and get the best dollar per IOP and IOPS per gigabyte. I think these are key points. We're not going after dollar per gigabyte. Dollar per gigabyte, guess what? There's HDD storage, there's QLC storage coming. This is for the performance tiers where people need more and more performance. And why do you need more and more performance? You have more and more applications that are requiring more throughputs. I think Manish talked about the GPU type of applications. There's in-memory databases. Those things need more and more bandwidth and performance. How do you do that in an effective manner without over-provisioning your building block? Is to have a disaggregated architecture that scales linearly. View this as an optimized unit of scale for storage disaggregation. So let's compare the solutions. You have the traditional model today that people are using to disaggregate. They put, there's SmartNIC products by a few companies. There's the x86 type of server architectures with NICs in front of them. That's the current architecture. They put PCIe switches on the backside, and they talk to the SSDs. That's limited performance because your bottleneck, again, is the CPUs and the NIC. Very high CPU power and DRAM power. Don't forget about DRAM. That architecture I just showed you in the previous slide had no DRAM inside the EBOF. Guess what? DRAM is very, very expensive these days, and no signs of coming down in the foreseeable future. So DRAM's another big thing you take out of this, right? So that's, again, lower your bill of materials, and I'll show you in a few slides here, lower your TCO, which is actually the most important aspect of this. Because if you're a data center operating at scale, your operational costs are more critical than actually your CapEx. Because you're willing to spend money on CapEx if you're going to have better TCO at the end of the day. So the EBOF at the bottom gives you simple, native, scalable performance with extremely low power and low latency. I think this is the key message I want to get out there, is the NVMe over Fabric architecture that happens at the drive level enables you to optimize your latency. Now, what's good about this architecture, to my friends on the startup community that are doing computational SSDs, doing intelligent SSDs, guess what? You can put your SSD behind it and bridge it into this market. So this enables anyone's NVMe SSD to plug into this infrastructure. This is very powerful, right? Because you have new models that are coming into place where no one really knows how these SSDs will evolve over time, but having it to be able to share it across multiple servers helps the data center and their customers to utilize that technology in a very simple manner. Because they don't have to go plug it into that SSD and say, oh, is anyone going to use that in that server? Guess what? Now it's shared, they can use it. So from a TCO perspective, which again, I think is the key thing here, and I'm excluding the SSDs because you're going to use an SSD in either case, right? It's the same SSD. Now you're just using these bridge controller type of products to go against the server CPU DRAM NIC architecture. And if you do the total cost of ownership, so meaning power, the costs of the bill of materials, you have approximately at least 65% TCO savings. So that's very significant. We have a POC running right now in Toshiba's booth with our partners Opera, who actually built the EBOF. Now, if you take a look at this, this is actually even one more step further than what I just showed. I showed you more a single ported NVMe SSD, NVMe over Fabric SSD. This is showing that our converter controller can actually enable dual porting. Why does that matter? Dual porting, as you know, in the enterprise environment is required for high availability. You have two paths. Today, SAS does that, right? But who believes SAS has a long life ahead of itself in JBOFs? None of us, right? This helps you scale in an enterprise environment with high availability with NVMe technology. So you get dual ported 25 gig coming to the drive and scales linearly. And inside the Toshiba booth, you'll see over 14 million IOPS. So this is not slideware. This is real stuff happening right now with their SSDs sitting behind it. So they have obviously high-performance SSDs that are gaining share that we really appreciate Toshiba collaboration. And now they're taking it to the next level to really scale out for the future data center. And you can see what goes inside the SSD. It's an interposer card. I think some of you probably remember from the SAS SATA world that people took SATA SSDs or HDDs, they put a SATA to SAS dual porting interposer to plug that into the enterprise storage infrastructure. Similar concept, only here you're taking it up to the next level where you have 25 gig pipes, NVMe over Fabric type of solution. So in summary, cloud and data center are right now, cloud and data generation era is actually driving the need for new architectures and really software-defined architectures. Why do I say software-defined architectures? Because you don't know what the workload's gonna be. If you know what the workload's gonna be, then yeah, you can build an optimized box for that. But guess what? None of the cloud providers know what the future's gonna look like when you're delivering a service. None of the enterprises know because their data sets are changing and their requirements are changing. The current converged server and disaggregated architectures, I showed you why they're challenged, right? They're challenged to scale because of the bottlenecks of the NIC, the bottlenecks of the CPU from a latency perspective, and the power of the DRAM. You know, that's a significant challenge that if you put something in the middle of the whole line, you can't get faster if that's a honking piece of silicon that has a lot of latency through it, right? And the NIC has only got so much pipes in it. And think about it, optics are also very expensive, right? So as you start to move from 25 gig to 56 gig to 100 gig to 200 gig, the cost of those links are actually going up too. So you want to minimize that type of links as well in your infrastructure, which is also why the data centers want to move away from that type of architecture longer term. The Marvell NVMe over Fabric SSD converter controller is a building block. And I think this building block will enable the innovators in this room and the data center innovators and enterprise folks to actually come up with new architectures. I showed you a couple of architectures. These are not the only architectures. And one thing I didn't even touch upon today is people are using this converter controller to actually put in front of HDDs. Why do you want it in front of HDDs? If you have 48 HDDs and you want a common infrastructure to manage this, meaning software management, you want to put it between SSDs and HDDs, NVMe is that commonality. So with our converter controller, as well as some other chipsets that Marvell has, and you can come to our booth and check it out, we can actually virtualize all that HDD to make it look like namespaces to an NVMe host. Simplifies the data center operator's job. Again, back to TCO, making it easier for the data centers to rent out their precious, critical resources. And this is an infrastructure building block that we're super excited about. And I think if you look at that JBOF I showed, the end-to-end 24 drive 2U box that Toshiba, Opera, and Marvell partnered on, you'll see how it scales. You can take the drives out, plug them in, and you'll see the performance keep scaling linearly. This is a key point, linear scalability going forward. And I would encourage everyone to visit Marvell's site, Marvell's booth, as well as Toshiba's booth to see some of the innovations that we're providing. Thank you very much.